Hi, I'm Clee Irwin, the founder of Quantum Gravity Research. Hopefully, if you're watching this video, you share some of our beliefs. We believe that there is no fundamental separation between spirit and matter. And matter for us is mathematical physics, because the more closely we look at nature, the more beautiful and intricate we see the equations and the mathematics. So we live in a beautiful mathematical reality. Now, how does that make contact with some of our spiritual experiences? Are those just imaginations in our minds that have no connection to physics? Or is there some new paradigm in science that we just haven't discovered yet? That is the mission of quantum gravity research, the unification of spirit and matter. And we've used money that I've mostly donated. We're a nonprofit, and I pretty much donate all the money so far, and that's been about $10 million. And over these years, we've produced about 100 peer-reviewed papers in mathematics and physics, and the interpretations of quantum mechanics, like why it is that a conscious person measuring and observing something physical changes the physical behavior of the system. So we work on these problems at the nexus of spirituality and consciousness and mathematical physics. And we want to keep going. We're not finished with our mission because we haven't fully unified spirit and matter in a way that is making predictions of physically realistic behavior. But we feel that we're getting closer, and we've had to lay off some of our scientific staff. We've had to do a 40% reduction in our budget because I have run in personally to some temporary financial challenges. And I've never reached out to the crowd, to our followers. I've really never asked for money because I'm not comfortable doing that, actually, but I'm asking now. I really need your help. The whole team at Quantum Gravity Research needs your help. We don't want to lay off any more people. We want to keep pushing the mission forward. We want to lean into it and finish the mission. And so we're asking for $1 a month. If you feel moved to help with more, great. But at least $1 a month from enough of our followers will help us get over the hump and help us stay in the game to keep pushing forward with this mission. So I appreciate you even considering the request, even if you can't do it. And thank you for believing in the power of ideas and consciousness to change the world. Please click the link in the description below to join our giving circle. Welcome, everybody. This is the first episode of a channel that we're starting here at Quantum Gravity Research. Our channel is called What is Reality? We'd really appreciate it if you subscribe, like, hit notifications. We're a nonprofit, and your support helps us bring this thought-provoking content. So enjoy. I'm your host, Clee Irwin. Our co-hosts, Azar and David, both staff members here at Quantum Gravity Research. The interesting thing to kick us off that you, Azar, were bringing up is the Fermi paradox. Is that right?
Yeah, exactly. So isn't that evidence for life not existing in the universe?
Right. So the Fermi paradox could be used as argumentative evidence that humans might be the first life, intelligent life, and that life on Earth might be the first life. It's not proof, right? But someone who believes that could use the Fermi paradox to argue that. And so for the listeners who don't know, the Fermi paradox is a mystery, a paradox, a mystery, enigma, right? You have a very large number of planets in the universe that have liquid water. And one would think that perhaps where you have liquid water, and other atoms, you should be able to have life every so often. And then further, one might think that where you have life, you have intelligent life that's capable of discovering physics and using physics to create technologies that would make manipulations in the electromagnetic spectrum. Like I Love Lucy episodes broadcast 50 years ago are manipulations of an electronic or artificial sort to the EM spectrum that somebody a long distance away could pick up. So anyway, back 40 or so years ago, Carl Sagan and many scientists convinced Congress to fund NASA with a very large amount of money to do the SETI, the Search for Extraterrestrial Intelligence. Right. And part of their argument was along the Fermi paradox line of thinking, which is, well, there absolutely must be life out there because the universe is so big and there's so many planets with water. And so they looked and they listened in countless billions of directions and distances in both time and space for the better part of the last half century. And recently some of the scientists involved with the original SETI programs say that we're just shocked. It's so quiet out there in the electromagnetic spectrum in terms of artificial signals that you can hear a pin drop and it is as though we are the first technologically advanced life form in the universe. We did not expect this. So that's the paradox.
So we recently came out with this paper called The Self-Simulation Interpretation of Quantum Mechanics. What do we think this has to relate to this topic in terms of UFOs, in terms of time travel, coming backwards in time? If we might be the only if humans might be the only life out there in the universe right now, then how could we be seeing these UFOs?
Yeah, let's break that apart a little bit and talk about the Fermi paradox. Made some assumptions, right? Okay. They assumed there are a lot of planets with water. Turns out that is a true assumption, and when they made those assumptions 40 years ago, they didn't know as much about observational astrophysics as we've got today in the post-Hubble world, right? So they were right about that.
Okay.
But one of the assumptions that they made is a mistake about what evolutionary biology does and what its objective is, right? Not saying it has a conscious mind and has an objective like we do, but biological systems tend to have objectives. And a biosphere, right, on a planet is, in the broadest sense, a living organism, right? An interactive, self-adjusting, self-regulating system. And systems can have something that is like an objective. They want to persist over time, and they adjust to do that. So is a biosphere that has a lot of animals like this one, is it the goal of the biosphere for its self-regulating survival to crank out an animal that has incredibly powerful abstract thinking ability, like humans? The ability to discover the fabric of reality and mathematical physics, and then create machines that can manipulate the electromagnetic spectrum, like radios. Because that's what the Fermi paradox is about, is they're presuming that evolutionary biology sort of climaxes at intelligence like humans. But that's wrong. Biologists don't tend to think that. So I'm going to give a couple evidences that humans may be the first high consciousness life in the universe, and you guys could let me know what you think. So first of all, It's hard to believe that humans would be the first, or that Earth, right, would be the first place where life occurred in the universe. Now, somewhere it occurred first, right? And if animals there were smart enough to wonder if they were the first, there should be another animal smart enough to say, well, how arrogant you are to presume we are the first. And yet they, in that case, they would be the first, right? Because we're defining them as the first.
Yeah.
So it could be the first place life emerged, but probably not. And that gets to the issue that I was mentioning about the objective or the behavior of evolutionary biology. So we have 10 million different animals on this planet right now, from microbes to butterflies to rhinoceroses. And in the fossil records, we have implications that there were about another 90 million species that came and went. So that's 100 million species, and those span 1/3 the age of the universe. So it's over 4 billion years, and the universe might be about 14 billion years old, let's say, and so about 4.5 billion years or 4 billion years of life here. So you got 1/3 the age of the universe on this planet, 100 million different animals, and only one that has achieved such grotesquely extreme, out of balance magnitude of abstract thinking ability that we have the ability to tell stories, invent science, collectively send people to the moon and to equipment to Mars, discover quantum field theory. And why would it be only one? The evolutionary biology process is a process of what's called symbiosis, where two or more living things efficiently share an energy landscape and exchange energy in a way that propagates both species and creates more complexity in that little biome. So that means that if any creature in a biosphere or in any predator-prey system were to become significantly stronger, faster, smarter, then its opponents, competitors in that predator-prey system, it will snuff itself out by dominating and thereby choking off its supply of symbiosis and food in the system. And this happens all the time. This is a standard understanding for evolutionary biologists. Humans aren't even close. Like, you can take the brain to body mass ratios of the next smartest animals on this planet, and it's not even close. It's freakishly beyond any other animal. And the uniqueness of our size of prefrontal cortex and what we're doing, right? We have the ability to create atomic bombs and destroy the biosphere. So the point is that might have been one of the oversights of the people who set up the SETI program and who focused on the Fermi paradox, is that it's a little bit of a sloppy or aggressive assumption that, well, wherever there's life, it must culminate in humans. No, sharks are much more evolved for their environment than humans. We're still in the middle of evolving out tonsils and our pinky toe, right? We're not fully baked yet, whereas you can go to certain other animals like sharks and you could see millions of years where that species of shark doesn't change in its niche because it's been practically perfected. Abstract hyper-consciousness is it's what we like. And it's what does our technology and what allows this podcast, but it's not necessarily what a biosphere, right, is aiming for. That's one of the big things that could be used as a straight-faced argument that we may not be the first life in the universe, but we might be the first hyper-intelligent, technologically endowed life. I'm leaning that way because of the SETI, the lack of the quiet as a pin drop evidence. And by the way, we're just getting started as a universe. The average solar lifetime is about 10 billion years old, which makes our universe about 1.4 solar lifetimes old. And most of the models for cosmology allow countless solar lifetimes before the end of the model. The big fizzle or a big crunch or whatever the cosmological model is, they allow all of them far more than just 1 and 1.4 solar lifetimes. So we're early. And some of that 1.4 solar lifetimes, no life could exist anywhere because some of it was just too hot everywhere in the universe. Maybe we're the first.
So if there's not that many high intelligent life forms out there, do you think these UFOs were man-made, or do you think they could be coming from some other source?
Oh, good question.
Yeah, I mean, it is a good question. I know you tried to connect it before I rambled on there just now to the self-simulation hypothesis, which that's a paper that's getting a lot of reads and that we published. David, you're a co-author. Marcelo is a co-author.
I think we should cover the basics for the self-simulation hypotheses just for our audience.
Okay.
Yeah.
Yeah, and then we can relate it, like you said, David, to this this Fermi paradox question and this question of, hey, hypothetically, let's say, you know, that these people in these congressional hearings lately are telling the truth, and that all these people all around the world increasingly seeing these phenomena, some of them that can't be explained. Many of them can be explained, right? But it's starting to get to a point where you're surveying people, and do you believe in extraterrestrial life? The majority of scientists believe it's out there. And then a smaller number of scientists believe that extraterrestrial life has made contact with us, but that number is growing. And so the basics of the self-simulation hypothesis. First, we follow the implications of quantum mechanics pretty religiously, and quantum mechanics implies for us and many mathematical physicists and quantum field theorists that fundamentally reality is made of information.
Okay.
And if reality were made of information, then one would have to agree on what information is. So I suggest that information is meaning conveyed by symbolism. For example, zeros and ones, right, are symbols. And if you order them in a certain way according to a language, you can have, you know, bits turn into bytes, which can turn into higher level structures in a digital code, or a bird language, right, or a spoken language. Any form of meaning that you find in science or elsewhere, it's going to be communicated in a language or code theoretic manner. Okay. So I tend to like this definition of information as meaning conveyed by symbolism. What is a symbol? A symbol is anything that can be thought of, right? In math and set theory, an object is anything that can be thought of, and any object can be a symbol. And meaning, well, that gets weird, right? Because meaning is a substance that entities capable of ascribing or recognizing or creating meaning traffic in. So we as humans, we deal in meaning. This whole conversation is about meaning, right? We walk around the world and, oh, that's a pretty sunset, and that, I need some food, right? Everything is meaning. And we are conscious. So we don't know if a grain of salt is running around ascribing meaning to things. If information is meaning conveyed by symbolism, and if meaning requires an entity capable of ascribing meaning, recognizing, attributing meaning, then it might be tricky to try to surgically separate the term information from the term consciousness. And here's where the problem is. Scientists don't agree or really know what consciousness is. At Quantum Gravity Research, we focus on the nexus of consciousness and mathematical physics, and we admit that we don't know exactly what consciousness is. We just know a few things that it seems to do. It's really spooky and mystical. It gets very philosophical, like what is this stuff consciousness, right? And what if it were foundational to the very definition and foundation of reality? So in the self-simulation hypothesis, we say this. We say, is it possible that our descendants will continue to create increasingly realistic simulations? And we say, yeah, probably. If mankind doesn't destroy itself, our simulations should get more real and eventually culminate in indistinguishable from reality, right? Midjourney can simulate an image that's now indistinguishable from a photograph. And some of the multiplayer video games this year are really, really getting super realistic, right? Okay, so we say yes to that. Okay. Our descendants in the future, they're gonna make simulations that are indistinguishable from reality. And will any of them ever make a simulation that we could call an origin simulation? In other words, run physics from the Big Bang forward and watch society and evolution, or just start it off at some arbitrary point, like just start it off with the physics and with the behavior of reality in the 20th century, right? And just let it play, or the 16th century and let it play. Now, again, this is really science fiction-y because you'd have to imagine computational power that is vast, but we've seen computational power doubling for the last several decades. So we say, all right, that's all plausible, that our descendants can do ancestor simulations that arrive at themselves. So they're doing a simulation and then it gets to a society similar to where they're at. You know, you have Elon Musk and so many other people out there saying the simulation hypothesis is probable. It's probable that we're in a simulation because if 2 or more of our descendants were to run an ancestor simulation, and that would mean that we have a 2 out of 3 chance of being in the simulation and a 1 out of 3 chance, if there were only 2 that ever did it at any point in the future, then we would have a 1 out of 3 chance that we're the one real reality, right? And they basically say, well, if it's gonna happen, it would be countless millions of such simulations that all of our various descendants do. And so therefore it's a very small probability that we're in the one real reality. That's the simulation hypothesis, right?
That gives me the chills.
There's an alternative, which is, well, what if we're in a mental simulation? We usually have about 7 dreams per night called REM cycles.
Right.
And we usually get pumped in those dreams because they're so utterly realistic that we really don't stop in those dreams usually to question, hey, wait a minute, this is fake looking and I'm in a dream, right? We don't usually do that. I don't know about you, but I haven't asked that question since I've been on the couch with you here because it's too realistic. Why would that even cross my mind? The Homo sapien mind is capable of doing very high fidelity simulations. We call them dreams. And computers in the next year, 2, 3 are gonna also get to be equally high fidelity. What if consciousness could become bigger and run a simulation of itself in thought, in mind space? So we can ask a new question. We can say, are humans the upper limit of what consciousness can be according to the laws of physics as we understand them? Most people would say no. That would be arrogant, and there's no good logical reason to assume that we're anywhere near the upper limit of what consciousness can be. And can there be other forms of consciousness? Like, could there be, hyperdimensional consciousnesses, such as a consciousness smeared across time, right? As opposed to us one moment at a time conscious beings. Could there be something similar to the idea of a collective consciousness, like the Borg in Star Trek, right? So can there be many different forms and species of consciousness, and can there be many different magnitudes for each of those species of consciousness? And I think we have to say, probably, I guess, if the laws of physics don't prohibit that,
right,
then given enough time, whatever is possible in the laws of physics eventually occurs. So we can say, forward in time of us, some distance, statistically speaking, there should be some consciousness that so vastly eclipses our consciousness, either in just sheer magnitude or form, like a completely different form of consciousness. Then we would be a little mini trivial version of that consciousness, and we can do full-blown photorealistic dreams, where light triangulates with perfect trigonometry off of dream chandeliers. And if we can do that, then an emergent future consciousness, far vaster than ours, that emerges in the evolution of reality the way humanity did, could run, in principle, the simulation, right?
Mm-hmm.
Like on a mathematical game board, I'll call it. So they think of the mathematical substrate, and then upon that mathematical substrate, they run algorithms, or you could call them simple programs. And certain simple programs can play out, such as cellular automata. And certain types of simple programs can give probability spreads, I would call them. Mm. So it would say, well, this can happen in the evolution with the probability of, 20%, and then this can happen in the evolution with a probability of 1%, and so on. And so that reality then, let's say, is just like our reality, and you get to the point where this emergent conscious entity capable of running the simulation has run the simulation. So you have to allow object, I think, David, you probably had the idea in our paper, the self-simulation hypothesis interpretation of quantum mechanics, to call that thing that goes across time a strange loop. And I thought that was a great name. A feedback loop is really just where two things are influencing one another, like a guitar string or two birds in nature, any two things that are influencing one another in a sort of communicative way. Vibrations or sound or anything is going back and forth. A trans-temporal or a cross-time feedback loop would be a case where something in the future is influencing something in the past, which is influencing that thing in the future, which is influencing that thing in the past. A feedback loop between two systems across time. So in our paper, we argued how our version, this interpretation of quantum mechanics, proposes that all things are in different degrees of co-creation or influence across time and by great distances in space. So by a kind of instant connectivity. If that were how reality is, then when you think about our descendants in 100 years or any point in time, and by the way, most of our descendants will not be human, and they will be alien. They won't be human because their DNA won't be encoded in a way that defines them as Homo sapien. Think speciate. So there was one way that we arranged DNA 4 billion years ago when the first microbial life existed on Earth. And then that DNA got rearranged many, many times, 100 million times. And so there have been 100 million different arrangements of DNA to make the 100 million different animals. So we're all cousins. with the lizards and butterflies and dinosaurs, right? We all came from the same original mother DNA. So if you kind of say, well, let's jump off from humans, which is just one arrangement of the genetic code. And we say, well, if that were the first, we just take the branch of the tree from there, then going forward in time, we will fractally branch out. It's called speciating. So we will speciate, and it'll branch and it'll branch, and given enough time, there would be more than 100 million different species that branch out from us. Most of our descendants will not be born on this planet, and the vast majority of them will not be human, and yet they will be our descendants. So our descendants forward in time may be able to develop an understanding of physics and quantum computation and have the ability to create ever more impressive simulations indistinguishable from reality, including their own self-simulation. And if that were to be possible, then it gets into a little bit of an enigma, because then you say, well, wait a minute, if they were capable of running a self-simulation with fully realistic physics all the way up to the evolution and emergence of themselves, then can we just loop that into a circle and reject linear causality or linear time? And there's implications in quantum mechanics and even other physics that we can reject linear time. But if you did do that, now you don't need a real physical reality. You can say it's all made of information, in this case, consciousness. And you could say that the simple program playing as algorithms on the mathematical game board lives in the mind of this emergent thing forward of us in time, our descendants, and it emerges, it comes from itself. It's bootstrapping itself or self-actualizing or self-simulating. To me, with the Fermi paradox, with the SETI program coming up bust, which, by the way, they were looking in the past.
Right.
They never looked forward in time, because we don't have the technology to do that. It may even be prohibited by physics, perhaps, to move, to do that, unless you can get particles to travel it faster than the speed of light. The point is, we were looking in the past. And if we could look in the future, we would see, of course, all of our vast fractal network of descendants. But we don't see that. So that's what the SETI was. So now we got these things supposedly visiting us. Aliens, ETs, and they're reporting weird stories from people who see it. These things blip in and out. They're just there and then they're not there. And sometimes they're amorphous and almost like plasma. And then other times get reports that they're solid, or that they morph from looking solid to being amorphous looking or vaporous. Whatever the heck these things are, perhaps our descendants in the future have learned about some sort of connection between whatever consciousness is, we say we don't know what that word means exactly, and mathematical physics. So the self-simulation hypothesis is an attempt to try to connect those ideas of consciousness with mathematical physics, because it is a mathematical universe. So if one wants to say that the universe is the ground of reality is consciousness, if they had some kind of metaphysical philosophy like that, it's possible it could be true, but we can also say, well, whatever it is, it's behaving very mathematically at the fundamental level.
So with that being said, I have a question. How does emergent theory relate to the self-simulation hypotheses? And can we actually cover, the basics of emergence theory?
The self-simulation hypothesis is agnostic to what the mathematical game board is and what the algorithms or simple programs or equations are that would play out on that mathematical substrate. Emergence theory is what we call a toy model. And so that's when a scientist has a conceptual framework for something that is developed enough to call it a model, but not rigorous enough to have physical realism and equations, for example. So emergence theory is a toy model that we work on here at Quantum Gravity Research that fits within the framework of the self-simulation hypothesis interpretation of quantum mechanics. And it focuses on this mathematical game board called E8. So E8 is an algebra called a Lie algebra, and it has a geometric object associated with it called the E8 algebraic root lattice. And that's an 8-dimensional object. You can call it a crystal if you want. It's an 8-dimensional crystal. And it has very powerful and special mathematical qualities that a lot of physicists and mathematicians appreciate, such as its association with the largest division algebra, the octonions. It's also the root lattice point set is the densest packing of 7 spheres or 8-dimensional balls in 8D. And as a group, it's a Lie group associated with these algebras. It's the largest of the exceptional Lie groups. So all of these 3 things make it beautiful to mathematicians and useful to some physicists. So we start with that as the game board, and it also includes other algebras, sub-algebras, and sub-lattices that have been used by others in various physical models. So when you take that, you're getting a lot of other goodies along with it. It's called an algebraic stack. And so we take that and then we transform that by projective geometry to a lower dimension and by a certain angle. And what we get is a quasicrystal. Have you ever seen like a mosque and they'll have these tiling patterns that don't repeat like a checkerboard, and they're very beautiful and they're made of tiles. So that's called a quasicrystal. And those quasicrystals are shadows or lower dimensional projections of higher dimensional crystals. So crystals are things that repeat like a checkerboard, and a quasicrystal is a pattern that is very orderly and it's a language or a code. It has syntax, but it doesn't have to repeat, like English. Like it's against the law in English to say the dog ran cat. But you don't have to say fast. You can say the dog ran slowly. So that's syntactical freedom within a construct of rules, and we want a code. And we want a lower dimensional thing, but we want that to fully encode the mathematics of this E8 Lie algebra and its associated, its equivalent mathematical representations. So then the game that we play on that quasicrystal code, you can call it an algorithm, you can call it, like in chess, there's an algorithm by which the knights move and the bishops move by a different algorithm. And so they all have these algorithms within the game with some syntactical freedom. And so with these algorithms playing, they make patterns in a probability distribution of how particles are going to interact. And there's millions of possible games that can meet those definitions. And we don't know, the scientists at QGR, we don't know what game is the right game, but many of us are convinced that we have the right game board. We just don't know what the right game or algorithm or simple program is. But we have some intuitions, and that's what we're working on nowadays when we're not filming a podcast like this, right? That's the toy model of emergence theory. And if you connect it with the self-simulation hypothesis, you can say, well, Clee, wait a minute, what's that game board made of? We'd say, well, it's a thought within the mind of some bizarre, emergent, pan-consciousness substrate that can, in principle, emerge in the future. And then bootstrap itself by self-actualizing itself, self-simulating.
Wow.
And so it's almost a mystical or spiritual viewpoint, but I like what Arthur C. Clarke said, where, since physics is always and science is always advancing and leaving earlier theories relegated to the dustbin of incorrectness, that he said that which we label today as magic and taboo or supernatural, right, outside of physics or nature, often later gets pulled into physics, but it has to be tomorrow's physics, new physics. So unless we at this point have reached the end of the road and completely discovered the ultimate unifying theory of everything, we should expect that we're going to discover aspects of our current assumptions about physics that are incorrect and are going to be replaced by new views. So maybe in that new view, the things that today people say are incredulous, like psychic phenomena, the experience of, synchronicities, the idea of, remote viewing, astral traveling, and even the idea of consciousnesses from the future being able to come back here and observe or even interact with us. Maybe those things can later not be metaphysics or mysticism or mere philosophy. They could perhaps turn out to fit into a future theory. So that's kind of what we work on here at Quantum Gravity Research.
Wow.
We're working on a new philosophy.
So as we've been developing emergence theory, one of the most inspiring things that you've been sharing with us in terms of guidance is that we can get inspired to understand how the fundamental laws of the universe at the Planck scale can actually maybe inspire new technologies in the real world. So what's curious is that we have this quasicrystal code potentially at the Planck scale, yet we also have quasicrystals in the real world which have a lot of rich and interesting physics. In particular, I figured I'd mention that it's been stated that Edgar Fouché, who is an ex-military researcher, claimed that quasicrystals were actually used in UFOs. And whether it's quasicrystals or other exotic materials, it's really exciting to see all the progress that's been happening with material science and condensed matter. For instance, there's metamaterials, and those have also been claimed to be useful for creating UFOs. And these metamaterials are complex materials that have intricate structure at different scales. So I just find it very inspiring that this notion of quasicrystals and the notion of different scales are coming into our work here.
So we really think, if we had to put our money on it, right? We think that at the very fabric of reality, where things get less physical looking and much more information theoretic, as you could say,
Right.
It's called the Planck scale. And if you take a meter about this big and you reduce it by 10, you'll get to something about that big, right? And if you reduce that by 10, you'll get to something about that big. If you do that 32 more times, you get down to this unimaginably small length called the Planck length. And quantum mechanics strongly implies that a length and a volume cannot be any smaller than the Planck length or the Planck volume. In that sense, it implies that reality may be pixelated, right? Where these Planck volume abstract little mathematical volumes are like pixels in some sense. And it also goes to time, right? We presume that we can just keep chopping a moment in half, right? Take a minute, chop it in half, chop it in half, chop it in half. You'd think that you could go to infinity in principle, right? But quantum mechanics also strongly implies that a duration, cannot be any longer than the Planck moment or the Planck time.
Any shorter.
Shorter. Oh yeah, thank you, shorter. And so that's even smaller in a sense. That would be taking a second and dividing it by 10, but doing that 44 times. So an unimaginably short duration, which at that point, since a duration can be no shorter than that, it's more like a frozen snapshot. Like how a 35 millimeter film or movie looks smooth and fluid, but it's really just paying attention to that 35 millimeter frozen picture and then pay attention to the next one and then the next one, and it gives you that illusion of smooth motion. So that's how many scientists today view reality, maybe what we call discrete or pixelated. And so if reality had the mathematical structure and symmetry of quasicrystals at that bizarre and absolutely small and high energy and short time scale, if it were quasicrystalline, right, the math, then as David alluded to, quasicrystals are fractal, which means self-similar at larger and larger scales, and smaller and smaller scales, self-similar, the same shapes, the same pattern, basically. And so our basic understanding of observable science starts at the angstrom scale, which is the distance between atoms in a copper metal, right? The distance between atoms is about an angstrom. So we know something about scales smaller than that with high energy particle accelerator collisions. But in terms of just like observing something with an electron microscope, right? We can see at that Planck scale, atoms way, way, way smaller than cells or than even DNA. But the Planck scale is 23 divisions by 10 smaller than that angstrom scale. So if you were going to design a metamaterial where you can arrange atoms and molecules, right? We can manipulate that through chemistry and other means. Then if you designed it, this is what the symmetry looks like, right? This is quasicrystal symmetry. So if something very mathematically abstract like this were at the very fabric of reality, the pixelated Planck scale, and then way, way, way larger at this angstrom scale, the atomic lattice scale, you were to create a material through nanoengineering or chemistry that matches this symmetry. What you could have, in principle, is something that you can think of as lossless communication, because it's fractal and where things communicate in waveform, but it's this discrete waveforms where they can only take on certain wavelengths and amplitudes because the system is fractal. And it's a long-winded way of saying, hey, when I found out from David about this scientist who worked at a high level in the military and reported as a whistleblower about how they did X-ray diffraction analyses on recovered metal from a supposed UFO recovery of material, and they found out that it was quasicrystalline, it kind of made me think, that is how I think our descendants are going to pioneer a whole new golden age of materials science by using quasicrystal materials. They're already known to exhibit very exotic quantum effects. But I think part of the reason is because of what might be the structure at the Planck scale fabric of reality.
Didn't Einstein say that time travel was impossible?
I don't know if he said that, but perhaps my guess is that he would have said that if he were asked, but who knows what he would say. But I think the reason he would probably say that is because of the way the question might have been set up. In other words, you'd have to say, well, Einstein, do you think that you can move a rock faster than the speed of light? He would say, well, no, I don't think you can move a rock faster than the speed of light. Do you think you can move a light beam, photons, faster than the speed of light? He would say no. And so without a lot of clarifying, one might assume if they're asked the question that they mean moving mass or moving people or bodies or spaceships through time to different times, which would generally require the craft to move faster than the speed of light, or to send a signal, a beam of light, right? Faster than the speed of light. So I don't have any really strong reason to believe that that's possible, although, David, there's warp drive technologies and there's loopholes and possibilities within physics, right, that can allow it. But what if whatever consciousness is can move around to different locations in reality? Different locations to the past, to the future, to different locations in the present. What if it can do that? And is there any legitimacy to stories? Like, have you guys heard any legitimate stories of like remote viewing or anything like that? So I think that there's been some legitimate stories about that. For example, the director of the CIA appeared on Nightline with Ted Koppel, and Ted Koppel asked him, was this stuff legit? Were you guys really having your scientists recording people remote viewing, right? Because that sounds like magic. And he just said, that, again, former director of the CIA, said absolutely. And it's going to require new physics to explain how the heck this could be possible. And then Ted Koppel was surprised because people might presume that the government shut down that program, right? That was a program run at Stanford Research Institute for about 21 years. It was funded by the government, partly by the CIA and partly by the US Army.
Wow.
And this is for 21 years. And they generated reams of data, and then the data got declassified. Anybody could look it up. All the scientists were legitimate PhD physicists, and I know some of them. I know 2 of them. And there are also university-level meta-studies on remote viewing. So there is scientific evidence out there that whatever consciousness is, it somehow seems to have the ability to access what physicists would call non-local information. Einstein would say, well, of course you exist tomorrow, unless you get killed tonight, right? But if you don't, you're probably not. Therefore, you exist tomorrow. You have equal existence tomorrow as you do today. And by the way, yourself yesterday exists with equal legitimacy as yourself today. And so in that viewpoint, can you move whatever your consciousness is to tomorrow or yesterday and look around? Could you do more than look around? Could you move your consciousness to tomorrow and somehow communicate with your consciousness, with yourself tomorrow? And the ultimate question is, can you move your consciousness to a different location in time or in space and influence energy there? So we already know with the Wigner and von Neumann interpretation of quantum mechanics that there are plenty of titans of physics and currently living physicists who believe that whatever consciousness is, it is involved in how, with the double slit experiment and other experiments, we see that observation or measurement changes the physical behavior. And there are many who say, no, it can't be, and it's not true. But many interpretations of quantum mechanics say that consciousness whatever it is, changes the physical system. So whatever consciousness is, if you moved it to a different location in time, could it change physical systems, energy, matter? Could it change the behavior of those systems? Or does it have to be trapped in an animal body right here where I do my observation in the double slit experiment? We don't know. But we need new physics, maybe, to answer questions like this.
And it's worth noting that while Einstein wasn't very happy with some ideas of time travel, the mathematician Kurt Gödel actually found solutions of closed time-like curves. So the mathematics of general relativity predicts that time travel is possible.
Right.
And Einstein also did a lot of other important work. For instance, he did work on entanglement that ended up relating to black holes and wormholes. So now it's understood that wormholes might actually relate to quantum entanglement.
By the way, David, your PhD what is in quantum field theory, specializing in amplitudes, right? And,
yeah.
And you did your undergraduate at MIT and then your PhD work at UCLA, right?
Yeah, that's correct.
So what you're talking about is the ER equals EPR concept, which is
exactly.
Isn't that Susskind and Maldacena, right?
Exactly.
So I'd like to riff on that. Some physicists nowadays are suggesting that space and time and energy and matter, which is a form of energy, are emergent, or what we call secondary, and therefore not fundamental. And it's actually an increasingly popular idea. And so Susskind and Maldacena are one of the many newer proponents of this type of idea that space-time and energy particles are emergent. There's something else under the hood that's even more fundamental. And so what they see is down at this pixelated level, they see a very abstract, it's not so physical there because it's before space-time energy and particles. And down there, this abstract level, they see a tangled network at the tiniest scale, or it's even before scale, or it's before space-time, of entanglement. And they say that those entanglement objects, they're very mathematical about it, are equivalent to very small wormholes. So Einstein's theory actually does allow time travel of animal bodies and objects, and that's the wormhole that we see in science fiction movies.
Yeah.
And it would take an enormous amount of energy to create a wormhole that a person could walk through. But in principle, there are solutions in general relativity that in principle, right, allow a wormhole, a traversable wormhole, to act as like a portal, right, or a tunnel, taking you from one location in either space and or time and another. And in principle, you could go back and forth and you could time travel in that way. That has nothing to do with entanglement, because entanglement is not part of general relativity. But if Susskind and Maldacena are onto a good idea, they're essentially saying, forget space-time and particles as being fundamental, and think of this very abstract mathematical thing where it's all these very, very, very small entanglement things that keep changing, right? Changing entanglement relationships. It's very dynamic. And from there, particles, space, time, energy emerge from effectively patterns in that entanglement pattern. So I really like that idea. It kind of reminds me of what we're working on with the toy model, emergence theory, where it's very probabilistic and we're seeing these probability spreads, and maybe we will have in the toy model something similar to the notion of entanglement. And if we do, then for us, all the patterns that we will call particles and the behaviors of those particles and their probabilities are going to come ultimately from the behavior of this simple program or this system of algorithms on the mathematical game board.
So what do we think about remote viewing in relation to all of this physics?
I can just speak from three directions. From one direction, I can look at a bunch of peer-reviewed research that's been published on it. Now, much of it has not been published because it can often be rejected by the good journals, but some of it has gotten through and gotten published. And then there are all the people I've met, like the PhDs who worked at Stanford Research, and I've personally met them and they seem to be genuine. So I can say there seems to be evidence, okay, that not all skeptics are aware of all the evidence. But it seems, if you look into it, there seems to be evidence. So that's from one supporting angle where I think it's true. The other is from my own personal experience and my son at a young age and other people. I've seen evidence of it. Didn't publish it, didn't really use the scientific method, but when you have enough personal experiences,
Wow.
that goes to your personal experimental edifice of what you define as reality, you know? So there's that. And then there is the self-simulation hypothesis interpretation of quantum mechanics, which seems to very clearly allow for consciousness to be able to move around, and that there's nothing in the self-simulation hypothesis paper that we published that says that a consciousness must strictly be always derivative of an animal body or an atomic or molecular motif of energy in space-time. It's more general. In the self-simulation hypothesis, we don't restrict ourselves to a narrow definition of consciousness or a narrow type of species or types of consciousness. And so the strange loop itself, by definition, is two or more systems, which both can be conscious, that effectively communicate or are connected across time, but not using mediating particles like light or electrons. This is a connectivity across time that is more analogous to the notion of entanglement, right? They're connected, there's emergent systems that are connected non-locally, and you have to have a viewpoint that reality itself is non-local, which, as we know, is very strongly implied by the quantum formalism. And it's been ruled out. What was it, Elaine Aspects experiment and
John Bell.
Bell, right? So that's been solidly experimentally tested, and I think that's the consensus view. There may be 8 outliers who think reality is not non-local still, but I think it's probably a consensus, at least at your level of training.
Yeah, definitely. Most people think that reality must be non-local. It relates to hidden variables as well.
Yeah.
And there's also an assumption of no retrocausality that is typically assumed there as well.
One of the things, if I could relate this to the retrocausality thing you mentioned, is the idea of the no communication theorem in quantum mechanics, which essentially is a theorem that says, yes, reality is non-local. Yes, things can be entangled across time, but no, you can't use that to cheat the system and have knowledge of a quantum state variable or what we call which way data. Let's say you have 2 slits and you fire an electron right down the middle, and it can either go through the right slit or the left slit, and the which way data is which one it went through. Okay. So you can't get that fundamental information like the spin up or down of the particle, or these things that I call quantum state variable level information. And I agree that is true. Like, I believe in the no communication theorem to that extent. But the jury's still out for me on, well, what if I take a consciousness here in the present, like David, okay? And then I imagine, in principle, David connecting in this abstraction of consciousness space. So we don't know what that is, but even without knowing what it is, I know consciousness is real because I'm talking about it and it feels like I'm conscious, right? So I think I'm probably conscious. So David here is talking to himself, or in a feedback loop with himself, from next Wednesday, okay? He's not using photons or electrons or any mediator carrier particles. We're not even saying how it happens, but maybe it has something to do with the non-local nature of reality. And when David here gets the feeling of irony in the future, and then David back here in the present picks up on the feeling of irony. Well, irony is the furthest thing from a quantum state variable, like the spin up or spin down. And the no communication theorem was meant for which way data, spin up, spin down. It was meant for quantum state variables. It was not ever built to deal with a word like consciousness and irony or humor, right? So the jury has to still be out on that, but it should not be able to occur. Irony, that David of next Wednesday should not be able to use photons or, say, electrons, energy in any form to communicate with himself the sense of irony back here in the present.
And it's also worth clarifying that the SSH does say some things about how consciousness can work. For instance, it says that in terms of codes, it would have to be non-self-referential symbols. In the paper, we articulate how things typically studied in quantum mechanics would be the emergent physical information, which is self-referential symbols. And we know that quantum mechanics has things like the no communication theorem, the no cloning theorem.
Yeah.
But we know that this EC must be different in some way than this EP, so it really is an unexplored area.
Right. In our paper, we had these two symbols, right? We had these symbols called self-referential symbols and non-self-referential symbols. And then we had this thing called emergent physical information and then emergent consciousness information. So you said EC. So the emergent consciousness information is what we called EC for short. Azar, you might know some of this, but basically, if we still go back to the beginning of our conversation and agree that meaning or information is meaning conveyed by symbolism, and then we say, well, what is a symbol? A symbol is something that represents something. Okay, so for example, an F represents the sound where we move our mouth in a way and we make a sound, okay? Or it could represent other things, right? It could represent that you got a bad grade on a test in school. So that is a case where a symbol represents something other than itself. Then there's a special type of symbol called a self-referential symbol. A triangle, like an equilateral triangle, physicists tend to use to represent this idea called change, or the difference between two things. They call that the delta symbol. And whenever they say delta symbol, they know what each other means. It means you know, change. But you could also use an equilateral triangle to represent itself, so that in a language, every time we see that an equilateral triangle, we're gonna think, oh, that equilateral triangle. So that's a special type of symbol called a self-referential symbol. It represents or symbolizes itself. And I think that's what David was saying as he was tying it into this idea in quantum mechanics called the no cloning theorem, which says you can't make a perfect copy of information. And so whenever we think about a physical system, or when we think about a concept like irony or humor, every time I say that word, I think of a slightly different type of irony, and I'm in a different mood. And the idea of love, all three of us are thinking slightly different ideas. There is no identical love. And tomorrow, if I say love, my mind is going to come up with a very slightly different idea of love. I will never think of the same exact idea twice. And so that gets around the no cloning theorem when you're talking about the EC information. It's new each and every time. Have you played with Midjourney?
I have.
So you can put in the same prompt, like the dog ran fast, and it'll make a creative interpretation and a beautiful image of that. And then you do it again, and it'll be a different one. And if you do it 1 billion times, it'll be 1 billion different creative and beautiful images prompted by the identical prompt, the dog ran fast. We are like that. I can say love every day of the week until you die, and your generated idea of love will be different every single time. But when we think of 1 or 3 or equilateral triangle or 90 degrees, these are different, right? These are absolute things. Like, I don't tend to think differently about 3, the quantity 3, different days of the week. It's the same, but love every day of the week is a little different. You said you've had psychic experiences.
Yeah.
Like, tell us about that.
Well, the experiences I've had seem really non-coincidental. It just seems like they're really on point. Even some of the things they described ended up happening to me.
Like, what's an example?
I had a psychic come down and she said that I was gonna move in a few months, or I was gonna have something strange happen within my household. And I couldn't imagine what, because my lease wasn't up. And it just so happened that, I was living with someone and they moved out, and it just changed my complete living situation. That's just one example, but I've had those experiences time and time again. And it's really freaky and spooky, and I'm just trying to figure out, how does this all tie into time travel, or does it?
Have you had any weird experiences that you could say are?
I mean, I've certainly have weird experiences. I'm trying to think if any relate to time travel specifically. I'm not sure about that, but what seems to be interesting, what's curious about this is that scientists don't typically like to think about this. Maybe part of the reason is because they're so logical and so used to this EP information.
Yeah.
So it seems like a lot of these psychics are more intuitive or more emotional.
Yeah.
And so if we do think of EP and EC as actually being real, and we think maybe if we look at it from a quantum field theory perspective, then the quantum vacuum should have fluctuations of this physical and conscious information. So in some sense, there should be some way where maybe you could have someone who can remote view and use their emotional states to use EC to, maybe they can't identically copy what's happened in the past, but they can almost do a mid-journey re-rendering of the past. And maybe they could use their emotional states and their consciousness to view or remote view into the past.
I kind of resonate with that as a possibility.
It's deep.
I've had also what I could call supernatural experiences.
Yeah.
Some of them were, I would say, are psychic. And again, I've seen one of my young kids do it over and over.
Wow.
And I've had experiences directly myself. So I think that's real. I think it's what we would call a phenomenon that is an anomaly relative to current established physics. Anomalies happen all the time in the peer review physics literature, where experimentalists will bump into something in the lab and report and rigorously measure it and report on it. And often, not all the time, but still often, those observed results will not match with the most popular theory or model of the day that governs that system. It will be, in some cases, not allowed. Like, this shouldn't happen according to this model. So that's called an anomaly or anomalous result. And then generally the title of the paper will have anomalous or anomaly in it. So the point that I'm making is that anomalies in the experimental physics literature are not all that uncommon. It's just part of how science progresses, because usually experiment will trump, right, or supersede whatever the flavor of the day model or theory is. And then that's what kind of drives the creativity of scientists to try to unlock or unpack, like, gosh, what would be the correct or the newer theory that matches with the new experimental reality. And then it's not an anomaly. Then you get a model that allows or describes that, and then it's no longer called an anomaly. So let's say that the things that we've experienced that we describe as supernatural are actually natural. In other words, we call them supernatural today because they're anomalies. They don't match up with enough of the popular physics theories. And then in the future, turns out that they're explained, right, within a model, and they're not anomalies. What I believe is that our descendants will figure out some things that we haven't figured out. For one, they will figure out how general relativity and quantum mechanics are replaced by a new type of quantum field theory that unifies the old versions of general relativity and quantum mechanics. And wherein one of those two theories, and maybe both, might have to have some adjustments in their assumptions, right? Their underlying assumptions. For example, maybe general relativity will have to give up the assumption that space-time is smooth, right? Without any substructure. Maybe quantum mechanics will have to give up the assumption that it's to be placed in Newtonian classic space-time as it currently is.
Okay.
And in some quantum field theory, there could be other new things, new assumptions. And maybe that future theory, which could look a lot like some existing theories that are more arcane or not as popular, right? Maybe that theory that is popular in the future perfectly gives, validity to yours and my experience, seeing our consciousness accessing non-local spaces or information or meaning. And that's what I believe. So because I believe that eventually our descendants will get to that point of understanding nature and science and physics, it will be a future physics wherein it is a mashup of whatever the science of consciousness is of the future and whatever the new mathematical physics, the new quantum field theory, or some other form of unifying theory that not only unifies the theory of time and space, like general relativity is the best we've got, and the theory of everything else, the behavior of energy and particles, which is the best theory is quantum mechanics. Unifying those, what if consciousness, whatever that is, and meaning and language theory? We have one paper called the code theoretic axiom, which says that the fundamental mathematical and algorithmic behavior of reality is code theoretic, or you could say equally language theoretic. So I believe that our descendants and whatever these extraterrestrials or these UFOs are, I believe it's more probable that they are us from the future. After all, they are hominid, according to the people who think that they have seen physical bodies, or government workers who have claimed to have observed recovered biological material. It's often reported that these are hominid-looking things. Not human, but arms, legs, digits, two eyes, kind of nose thing, mouth thing, like clearly too coincidentally similar of an animal to not wonder, like, are we associated in any way? You look kind of like an ape also. You're just an ugly one, right? Right? To us, right? We probably look ugly to them.
They think we're ugly.
Right? If those reports are real. But the point is I believe that, from the reports I've seen, there's plenty of reports on bizarre psychic phenomena all intertwined with these millions of reports from all over the world. There was this one case in Australia that was heavily publicized by the standard media. Anyway, it was a children's school, and a couple hundred people were outside. It was like recess, playtime, and there were all these teachers outside, adults, and there was all these kids. And there was a sighting. So some of the kids ran over there, and a whole bunch of kids, I think these were like, 10-year-olds, they all claimed to see this craft, see these beings, and that these beings were telepathically communicating with them. All of the local evening news and all the reporters descended within hours, right? Descended on this school and started interviewing people live on the spot. The kids, the teachers, right? Adults who saw it, the kids, all, most of the kids saw it. And the kids who claimed to have the telepathic communication with these consciousnesses were all saying the same thing. Now, they could have just been collaborating to tell a big lie to get attention, but it would have had to have been like the whole school. So anyway, that's one of the most famous cases, and there's many, many others that report telepathy or psychic kind of non-local information connection, right, associated with this whole UFO phenomenon. My best theory for the time being is that our descendants hack reality to the point of understanding a powerful and predictive quantum gravity or similar type theory, and that it is information theoretic and it's language theoretic, which leads into thought and meaning being fundamental. And so therefore a kind of ability for meaning generating entities to access non-locally the underlying non-local nature of reality. It's the consensus that it's fundamentally non-local, and they're tapping into that somehow, and they've figured out how to do it, and it's become official, like scientifically official at that point. Here in the 21st century, it's not yet official, and I don't think it can be official, psychic phenomena as a reality, until there is a mathematically rigorous and predictive theory of reality that starts by explaining the apparent contradictions of the assumptions undergirding general relativity versus quantum mechanics. So I think that all pops through the membrane of scientific consensus, but not today. But maybe in our lifetime, maybe not. And that's how I see a connection between psychic phenomena and this whole UFO phenomena.
So we talked about how consciousness can move over time, such as with remote viewing, but do you think that consciousness can manipulate matter over time? And if so, how might that work?
Well, let's go as fundamental as possible first. We talked earlier about the Wigner and von Neumann interpretation of quantum mechanics and several other interpretations. And in these interpretations, it is believed that it is consciousness that collapses the wave function in the double slit experiment. The double slit experiment, you shine light or shoot electrons through a board that has two slits, and then the ones that go through the right slit are going to make it to the screen, and the ones that go through the left slit are going to make it through the screen. And so you would think that you're just shooting them through, and they make it through, and they're just going to create two stripes on the screen. But they create the classic interference pattern, implying that they were waves and not little balls like particles. When you have knowledge, and you measure, to have knowledge, you have to measure or observe. You can use either word. You have to observe or measure. So you have to do that to know which of the two slits the particle has gone through. So that's called the which way data. And if you know the which way data, well then mysteriously, the interference pattern collapses and it goes to the pattern you would expect it to have, right? And then you stop observing it, and you lose your ability to know which one it went through, and it goes back to the interference pattern. It's a very frustrating experimental result, and quantum mechanics does not explain itself to say what that means or what it means as quantum mechanics. And so you have these different people who are legitimately educated and could be similarly famous, and they'll have these very different views of what quantum mechanics really is saying, especially around this controversial issue of whether or not consciousness is necessary to do something called observe. I don't know what consciousness is, but I think I'm doing something called observation, which is a sort of sense of self, and then the relationship of other things to me, my sense of self. And although a grain of salt can have things hit it, like photons, I don't have any good reason to believe that the grain of salt has a sense of self. And I don't think a grain of salt, by letting photons hit it in that double slit experiment, can collapse the interference pattern. I think a conscious entity is necessary to do this action. So the point is I'm going fundamental to say that in that interpretation, the consciousness is involved in collapse, then it is consciousness, the knowledge, the awareness of the observation, which is collapsing the wave function. And collapsing the wave function is a very primitive example of mind over matter. In other words, the physical behavior of the system has changed. It will evolve differently just because of the knowledge that the observer had of it in this interpretation of quantum mechanics. So can you take your consciousness and project it to a different location in space and or time? And from that different location, can you observe energy and matter in that location, and just like in the double slit experiment, change the behavior of the physical system simply by the awareness which happens in this mystery of whatever the heck consciousness is? In principle, if such a thing were true, then one could say, well, how complicated and intricate could that manipulation of energy and matter be? Because with just one pixel on my iPhone, right, just one single pixel, and it's blue. It's not much, but if I can get a whole bunch of them intricately to choose which color, then I can get a high resolution 4 or 8K image that's indistinguishable from how I look at you guys and I see a flat, high resolution image. So maybe these descendants of ours that are speciated, not born on this planet, and can move their consciousness because they have the technology and the knowledge to a location, and then perhaps they can do anything from the extreme, which would be remolecularization, with something related to observation and how consciousness can influence wave functions. Or they can create sort of nebulous structures that are quasi-physical looking and kind of morph in and out of physicality, which is, by the way, what a lot of the reports from the US Navy and pilots and other observers have seen. Like, these things can look physical and then they start blurring out and then they just disappear, or they can just stay in a kind of amorphous, fuzzy type of form. That might be this idea of different skills and different techniques of our descendants. Because remember, if UFOs are real and it follows this idea that they are us from the future, they wouldn't just be from one future.
Right.
There's a branching trillions of futures and trillions of locations in space. Our descendant tree, right, going forward in time, is a zoo.
Thank you guys for this interesting, mind-blowing conversation. I feel like I learned so much that I didn't know. And thank you for everyone watching. This is our first episode, so please like, share, subscribe, comment below, give us feedback on what you guys think. We would love to hear it. And if you have any feedback on conversations you want us to have in the future, please share it below. Thank you guys so much. And that's it for our very first episode.
Thanks, guys. Hi, I'm Clee Irwin, the founder of Quantum Gravity Research. Hopefully, if you're watching this video, you share some of our beliefs. We believe that there is no fundamental separation between spirit and matter. And matter for us is mathematical physics, because the more closely we look at nature, the more beautiful and intricate we see the equations and the mathematics. So we live in a beautiful mathematical reality. Now, how does that make contact with some of our spiritual experiences? Are those just imaginations in our minds that have no connection to physics? Or is there some new paradigm in science that we just haven't discovered yet? That is the mission of quantum gravity research, the unification of spirit and matter. And we've used money that I've mostly donated. We're a nonprofit, and I pretty much donate all the money so far, and that's been about $10 million. And over these years, we've produced about 100 peer-reviewed papers in mathematics and physics, and the interpretations of quantum mechanics, like why it is that a conscious person measuring and observing something physical changes the physical behavior of the system. So we work on these problems at the nexus of spirituality and consciousness and mathematical physics. And we want to keep going. We're not finished with our mission because we haven't fully unified spirit and matter in a way that is making predictions of physically realistic behavior. But we feel that we're getting closer, and we've had to lay off some of our scientific staff. We've had to do a 40% reduction in our budget because I have run in personally to some temporary financial challenges. And I've never reached out to the crowd, to our followers. I've really never asked for money because I'm not comfortable doing that, actually, but I'm asking now. I really need your help. The whole team at Quantum Gravity Research needs your help. We don't want to lay off any more people. We want to keep pushing the mission forward. We want to lean into it and finish the mission. And so we're asking for $1 a month. If you feel moved to help with more, great. But at least $1 a month from enough of our followers will help us get over the hump and help us stay in the game to keep pushing forward with this mission. So I appreciate you even considering the request, even if you can't do it. And thank you for believing in the power of ideas and consciousness to change the world. Please click the link in the description below to join our giving circle.